right, today we're going to talk about our inverse variation graphs. So these look a little intimidating at first, but once you see how they're related to what we've done before, it's not that bad. So let's go through and let's talk about all the parts of it. So an inverse variation is a function or a graph, either or. It's a function or graph that never passes through the origin, and that's provided there's no transformations, meaning it's not shifted left, right, up, down, or whatever. So it never passes through the origin. There's two parts of the graph in opposite quadrants called branches. So there's this part is a branch, and this part is a branch. And in the parent function, so this is your parent function, y equals 1 over x, the x and y axis are both asymptotes. Now, there's two different ones. You have a vertical asymptote and a horizontal. So when you're thinking of this, your vertical asymptote, it goes vertically up and down, and then your horizontal asymptote goes left to right. So when you're thinking of this, your vertical asymptote is going to be your x equals a number, and then your horizontal is going to be y equals a number. So that's the equation for the line of that. All right, and then also an asymptote is an imaginary line in a graph that approaches, or the graph, it approaches, but it never touches. So it gets really, 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 really close, but it never touches the asymptote. And the intersection of the two asymptotes is a point called, there's different ways to say this. You can call it a foci, but I would say foci, there's other people say foci. So, but it's called the foci, and that's basically where your two asymptotes intersect, and this is similar to what would be your anchor point, your vertex. This is important because we need that point to help determine some of the other thing. And then just remember, as we did with indirect or inverse variation, we said as one increases, the other decreases, or it goes the other way too. All right, so we're going to graph the parent graph, y equals 1 over x, and using the table of values below. So what I did is, since it's a parent graph, I know my foci or foci is going to be 0, 0, because that is where the points are. So I put a point here. And then I'm using some of the points, and I tried to graph as many as I could on here. And when you're doing this, you're going to see it's going to get really, 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 really close, but it's not going to cross those asymptotes. And remember, these are curved. These are not. It's not a right angle. It's curved. And it gets really close to your asymptotes, but it never crosses. All right. So the domain in this case is, all you got to do here is look at what's happening to your x's, and you read this as x such that x is not equal to 0. And that is because you're going to look at your vertical asymptote. And your range is going to be y such that y is not equal to 0, which would be that, which is your horizontal asymptote. So if you notice, your branches are in quadrants 1 and 3. So if you were to look at y equals -1, that's going to reflect it. So just like we talked about with any cube roots, how before we said it would look like this, and we said when it was reflected it looked like that. So it's going to be the same or similar, where if it's reflected, it's now good, it would be in quadrants 2 and 4. So that's if A is negative. All right, so now let's get into this part. This should look really familiar. Now we just did a little something different to it. So instead of all the different ways that we've learned, so we've learned y equals ax minus h squared plus k. We've learned y equals a, and then we talked about the square cube root, x minus h plus k. So this should all look very familiar, very similar, where a is talking about how far away or how stretched or compressed it is. Well, in this case, the larger A is, the further away from the branches are from the foci or the foci. And then H is still the same. You're still looking at H, where it's going to be basically the opposite sign because it's always X minus. So H is the value of the vertical asymptote. So if H is positive, the asymptote shifts left. If it's negative, it goes right. So this is exactly what we've talked about before. And then for K, just like we've had up here, K is going to be the horizontal asymptote. And if K is positive, it goes up. If it's negative, it goes down. So this is all very similar. The only difference is now, since it varies inversely, remember we said Y is K over X. Since it varies inversely, your X is going to be in the denominator you're dividing by. All right. And then notice HK is still the same. But like I said, the foci is, we're using it that instead of a vertex or an anchor point. All right, so let's get started. All right, so it looks like a lot at first, but once you kind of get the hang of graphing it, it's actually not that bad, and you get to understand how all the other parts relate to this. So let's look here. I've got 1 is A. I've got my H is 2, and my K is 3. So now that we've got these pieces of information, we know our foci is going to be HK. Now, here's the cool part. Your asymptote, this is a vertical asymptote, is the equation of the line that the asymptote is. So you just take your H value, and that's your vertical asymptote, and you write the equation X equals. So then when you come over here, you're going to graph, and I read it as it crosses the x-axis at 2. So we do a dashed line, since it's an imaginary line. And then your horizontal asymptote is your K value. And you write the equation Y equals -3, because that's the equation of the asymptote, the line. So then I graph it as it crosses the y-axis at -3. Now, if we did this correctly, this should be where your 2 intersect. So if you notice, they both intersect at this point, which is your foci. So this is the main point that we're going to go from. So first off, A is positive. So we know it's going to be in quadrants 1 and 3. Now granted, we're shifting it a little bit, but the majority or where it is originally, this would be quadrant 1. If you look from where the asymptote is. All right, so you can go ahead and plot these points, or plot the graphs. I'm going to show you where I got those in a second. All right, but before we get to the actual graphing the branches, domain is pretty easy. It's your vertical asymptote, so X such that X is not equal to 2, and we put them in the curly brackets, or however you say it. Go ahead and you do the set there. All right, and then range is going to be Y such that Y is not equal to -3, and that's your horizontal asymptote. All right, so now how to actually graph these. Again, remember, it's not a right angle. So there's a couple tricks. First off, we know since A is plus, it's going to be in quadrants 1 and 3. But just like we had strategy when we were graphing our radicals, or square root, cube roots, we wanted to get a perfect square or a perfect root under here. Our strategy in here is we want to try to get the fraction to become an integer. Once it's an integer, then it's easy to add or subtract. So if I make this 1, that's actually going to make this 1 over -1 minus 3. And then that's going to give me -4. And then another way would be if I were to make this positive 1, it's going to be 1 over 1 minus 3. So again, and that's where we get our -2. So that's one way that we can start to get our points. And then truthfully for Math 2, we're not going to graph all the points, but you can always plug in other numbers. So another number that I might pick could be, if you pick 0, you're going to get -1/2. So that's not really going to help you. So those are usually the best numbers, but you can go through and you can pick any number that would make this a fraction. So you could do negative, positive numbers. It's okay. But also I do want you to notice something. Notice A is 1. So if you were to go from the foci, go up 1, over 1, and we're in the first quadrant, or if you were to go over and down, or over and down, if you notice, that's going to take us directly there. So we are one diagonal away from the foci. So that's just another little trick to figure it out. All right, let's go ahead, let's do this next one. And it says plot the asymptotes first, and that's going to shift where our axis, our XY axis is. So let's look here. Now, this one's different. A is going to be -1. So since it's reflected, we're going to do quadrants 2 and 4. So before, our branches were this way, which were quadrants 1 and 3. But since it's reflected, you're going to do quadrants 2 and 4. So let's go ahead, let's list the rest of the information. H is 3, K is 1, so put these together to make your foci. Once you've got your foci, then you can go ahead and do your asymptote equations. So my vertical asymptote is going to be x equals 3, and I'm going to graph that here. And my horizontal asymptote is y equals 1, so it crosses the y-axis at 1. And where the two intersect should be where your h and k are. So basically all we did was we took our xy axis and we just shifted it over and down. Or excuse me, up and over. So we went from here, up and over, and that's our new foci. So we shifted everything. So when we do this, again, the goal is you want to try to get an integer. So if I make this 2, I'm going to get -1 over -1 plus 1. And then I'm going to get 2. And then if I were to make this 4, I would get 1. So it's -1 over +1 plus 1. And then I'd get 0. So again, the strategy is just to try to get a whole number as the fraction. So once you've got that, then you can go ahead and plot those 2 points. Or, like I said, if you go, since I know it's going to be quadrants 2 and quadrant 4, I'm going to go up and over 1 from the foci. And then you can either go over and down or down and over. So either way works. But if you notice again, since A is 1, or -1 technically, since A is 1, it is one diagonal from there. And your domain, make sure you got your domain. Remember, this is your H, this is your K. And so it's saying it can be everything, any x except for 3. And then y, such that y is not equal to 1. So that's your domain and range. So then just remember your quadrants are 2 and 4 if it's reflected. All right, so I want you to try this one. And I'm going to do this one with you because it's slightly different. So if you notice here, A is -4. So there's a couple things you need to know. First off, it is going to be reflected. Oops, sorry, that snapped. And also, it's going to be in quadrants 2 and 4. So if it's reflected, that's where it's going to be. All right, so now let's look. We've got H is -1. And then K, since there is no K written, we know K is going to be 0. So we can write our asymptotes from here and graph our asymptotes. So x equals -1 for your vertical asymptote, and your horizontal asymptote is y equals 0. So it crosses the x-axis at -1, and then it crosses the y-axis at 0. So if you notice, we shifted our xy axis from here 1 over, which makes sense because that means you're moving everything that direction. All right, so again, we could make a table to where I could have x equals 3. And if I make this 3, that's going to give me -1, right? And then you can go through and you can just, if you make this +3, -1, And then another number I could put in here is I could put in -1. If I put in -1, oops, yeah, that's what I want, sorry. Oops. So you can go through and just figure out, okay, well, if I've got 3 is going to give me +4, I could do a -5 to give me -4, right? And that would give me +1. And then I could also pick, let's say I did 3. Oh, I could pick 2. I could make it 2, so I could make x1. And if I make x2, then you're going to have, or x1, you're going to get 0. Let's see, x2, it would be negative, yeah. So that would give you -4 over 2, which gives you -2. All right, so you can do that. Another thing I'm going to show you, though, is see how a is 4, or -4 technically, so we're 2 and 4. I'm going to go up 4 and over 1, so I'm in this, and then I'm going to go over 4, up 1. So 4, up 1. And then from the foci, I'm going to go over 4, down 1, and then I'm going to go down 4, over 1. So that's another way. Or you can sit there and you can make up points, but it kind of gets to be a little much. And then also, too, if you count 1, 2, 3, 4, so that's the diagonal that goes through 4 of them. So like I said, you can either make tables to find your points, and then like I said, strategies, get a fraction or an integer there, or you can go 4 from the foci and then down 1. All right, and your domain and range, remember, this is your h value, this is your k value, and I want you to go ahead and I want you to try all of these. So if you notice, this is 4 and this is -9. So remember, 4 is going to get further away from the foci, and -9, you're going to be in quadrants 2 and 4. So +4, you'll be in quadrants 1 and 3. So I want you to go ahead, complete the rest, and then that is your, oh wait, we have one more page to do. Sorry, I almost forgot. All right, just kidding, can't go anywhere yet. Okay, here we go. So now we're going to write an equation using the following. So we're just putting it all together. So this is what we're starting from, and it has the asymptotes of x minus 2 and y equals 3. Well, this is your h, and this is your k. So once you understand that, it's really easy to just put it all together where you would be, remember it says plus, but it's really a -2, and then this is +3. All right, I want you to try this one. And then here, if it has an asymptote, this, remember, that's your h, that's your k, but it has branches, and it's supposed to say quadrants, it was misspelled, 2 and 4. If it's 2 and 4, a is negative, so make sure you make a negative. And then this is your h, is -4, so you need to write x plus 4, and then k is k. So you can write it this way, where you put the negative up here, or you can put the negative out front. Either way works. All right, I want you to try that one. And last but not least, vertical asymptote of 5. So this is basically saying your x equals 5, which is your h. And then this one is your k value. So this is saying y equals -3. So that is your k value. So again, once you put it all together, and it's in quadrants 1 and 3, so a is positive. All right, and go ahead and try that one. And I just wrote this down here as a reminder for your formula. Okay, now, this is how you graph inverse variation.